In this video, we're going to continue our work on finding polynomials when we are given all the zeros. So in the last class, we worked on problems like this where we were given several zeros, each of which had a multiplicity of 1. So if you remember, to find the polynomial, we had to do the opposite of each of the zeros that was given to us. And then we multiplied whatever we had. In this case, we just have 2, so we can FOIL. And then we can combine like terms. And we end up with this as a polynomial. Now, it's important to note, and I don't think we talked about this, it's important to note that this is not the only polynomial that has those zeros. This is just a polynomial that has those zeros. For example, if I distributed a 3 or I distributed a 1/2, I could come up with all sorts of different polynomials that cross the axis at both 4 and -5, even though the coefficients are different. Any multiple of this polynomial will work as well. So the difference with what we're going to do today is that this time you'll see in parentheses a little MULT. Well, what that stands for is multiplicity. So what that means is this particular polynomial has 3 different zeros. 4 is one of them, and then -4 is a zero twice. So let's do that in your notes. So x minus 4, and then, because remember we have to do the opposite, right? So +4 becomes x minus 4, and then this -4, that's going to become x plus 4, but it has a multiplicity of 2. And you remember the multiplicity focuses solely on the exponent. So that means that -4 is a zero twice, which means I'm going to have x plus 4 squared because I have a multiplicity of 2. Okay, let me put my f of x here in the front. All right, now remember what squared means. Squared means multiply by itself. So I need to write that down 2 times and then FOIL it together. It's very important that you do not try to distribute the squared, because x plus 4 times x plus 4, well, that's going to work out to be a perfect square trinomial. And if you try to distribute the squared, you're only going to end up with 2 terms. And you heard me say it's a perfect square trinomial, which means it should have 3 terms. So distributing the squared will not give you the right answer. Okay, so let's multiply these together. And we did practice with 3 terms in class in our last unit. So I'm going to multiply those 2 together. All right, let's FOIL that out. So I've got first times first. And then I'm going to distribute that x over here to the +4. All right, now I'll distribute the -4. So I've got -4x minus 16. Remember, I've still got this x plus 4 over here on the side. So inside the parentheses, I see that I have some like terms. +4x and -4x are opposites. They cancel out. And so I have this, x squared minus 16, and then x plus 4. Well, that makes sense because look right here, I have x minus 4, x plus 4, and that was what we got when we factored difference of squares. So it makes sense that we should end up with a difference of squares binomial right here once we FOIL those together. All right, again, I have 2 terms times 2 terms, so I can FOIL those. So I'm going to distribute my x squared to both of those. And then I'll distribute my -16 into the parentheses as well. Okay, so there's my answer. I'll put my f of x again in the front. F of x equals x to the third plus 4x squared minus 16x minus 64. So if we took this and we graphed it, we would see that it would cross the x-axis twice. It would cross once over here at +4 and once over here at -4. Now on -4, it would have a multiplicity of 2, so it would bounce. So look, this is positive odd, means it's going to start down and end up. So positive odd, I'm going to bounce, and then I'm going to cut. So this should actually touch the axis. Sorry, y'all, when I draw with my finger, it sometimes doesn't work out properly, but it should touch the axis right here and then cut through the axis right here. which matches what we see here, and it matches the fact that it is a positive odd, it is a cubic, and it has 4 terms. It's a cubic polynomial. Okay, let's go to this one. So this time you guys can see that I have multiplicity of 2 twice. So I'm going to say f of x equals, and I'm going to have x plus 1 to the second, right? Because remember, I'm going to do the opposite of this. So the opposite of negative 1 is going to be positive 1. Multiplicity of 2 tells me that exponent should be 2. All right, now let's do this one. So I'm going to have x minus 2 squared. So again, I'm going to have the opposite of this one. And that multiplicity of 2 tells me what the exponent is going to be. Now we just said in the last problem that that exponent of 2 means that I should write it 2 times. And the x minus 2 should be written 2 times as well, because I have a squared on that. And so what I'm going to do, I'm going to multiply these 2 together and combine like terms. Then I'll multiply these 2 together and combine like terms. And then I'll multiply together the answers that I get. Both of these are going to work out to be perfect square trinomials because you can see I had a squared on both of them. Okay, so let's FOIL out this first one. So distributing the x, sorry, it's a little bit tight in there. And now I'm going to distribute the positive 1. All right, and now moving to the second parentheses, let's FOIL this one. So I'll distribute the x, and then I'll distribute the negative 2. Both of these have 2 middle terms that are like terms, so I'll combine like terms and combine like terms on this one as well. All right, now I'm going to need to do some distribution to figure out what I've got here. So let me change pen colors so we can follow along. All right, first I'm going to distribute my x squared to each of these. Okay, so I'm going to get x to the 4th minus 4x to the 3rd plus 4x squared. Okay, now I'm going to come back and I'm going to distribute 2x to each of these. So that's going to give me, actually I'm going to line it up so that my like terms are together. That's going to make the next step easier. So I will have positive 2x to the 3rd, and I'll put that over here, minus 8x squared, and then plus 8x. All right, change colors one more time, and I'll draw these rainbows on the bottom so you can see them a little bit better. I'm going to distribute 1, and again, I'm going to line up my like terms. So multiplying each of those by 1. All right, and then I'll just add straight down to get my final answer. So x to the 4th, negative 4 and positive 2, that makes negative 2x to the 3rd. 4 minus 8 plus 1, that's going to end up being negative 4 plus 1, negative 3. Positive 8 minus 4 is positive 4. And then plus 4. And I'm out of space over there, so I'll put my equals f of x on this side. Okay, so I should have 4 zeros because I see the highest exponent here is 4. And if I look in my parentheses, I can see 1, 2, 3, 4 zeros. It's just that they're not all different from one another. I have negative 1 as a 0 twice, and I have positive 2 as a 0 twice, but that does make 4 total zeros. So for my quartic polynomial, I have 4 zeros, negative 1, positive 2, and positive 2. And so if I were to graph this, it would touch the x-axis in those points. So let's do that. Let's put negative 1, and over here positive 2. All right, my leading coefficient right here, this is going to be positive even, so it's going to be up on both sides. And notice, because my multiplicity is 2, it's going to bounce right here, and it's going to bounce right there, and then connect over. So that is an example of what that could look like, bouncing right here and bouncing right here. This should not go through the axis. It should just touch and bounce off. But again, when I try to do that with my finger, sometimes it works out a little bit better than others. So that is what my polynomial would look like if I were to graph it.